Okay, so last week on Tuesday and Thursday, you guys had a lesson on types of acids and bases, and then one on acid-base neutralization reactions, which are just the specific type of chemical reaction that an acid and a base will do when they react together. So if you didn't do those last week, then you're going to have to maybe play catch up this week and get those done. But if you did do them and you have questions about anything, when we get done with today's lesson, I'll go back and kind of ask if you guys have any questions or if you want clarification over anything, since we didn't have our Zoom classes last week because of the testing. Okay. So for today, well, really for this week, okay, so for today, we're going to be talking about the pH scale. So it's just kind of a basic intro to like, what is it and how do you use it to kind of read and determine information about substances, like are they acids or bases or neutral. And then Wednesday, our last part of this unit is actually then doing calculations. So there's an equation that we can use to calculate pH and some other things. pH, hydrogen ion concentration, we can calculate what's called pOH, and then also hydroxide ion concentration. So all of this has to do with acids and bases and how we identify something as acidic or basic. And so that'll be the last part on Wednesday, is just doing calculations involving pH and some of those other things I mentioned. And then I haven't put it up yet, but Friday, your test will be up there for you guys, okay? So we finished this unit this week, and then next week, starting on Tuesday, well, you'll have 2 A days next week. You'll have Tuesday the 18th and Thursday the 20th. So, but for all of next week, I will be posting the reviews for the final exam. And then we'll talk later on Wednesday, because the review for the final is also going to serve as grade redemption for anybody who needs to make up 4th or 5th 6 weeks, or even the stuff from this 6 weeks, like maybe the solution stuff that you haven't been keeping up with, okay? So we'll talk more about that on Wednesday, and I'll kind of show y'all how that's going to work. But for today, we are looking at the pH scale. So I'm going to go ahead and go to this one so that we can kind of go through it together before you guys work on stuff. So the pH scale, so you go from acid to alkaline. Alkaline is like a synonym for base or basic. So if you hear the term alkaline, that means base or basic, okay? Acid, we always say acidic, so there's not really another word for that. But basic or alkalinic or alkaline base, those are all kind of interchangeable, okay? And so you can kind of see this meme here. So you have the pH scale. Bases they're going to go up to 14. Acids are going to go down to 0, and right smack in the middle at 7 is neutral, when that's where we find pure water. So pH is a symbol. It's the symbol. It actually stands for like the power of hydrogen, because when we're talking about acids, we're talking about the number of hydrogen ions, because all acids have hydrogen ions. And so pH is the measure of how acidic or basic something is. An acid is going to be something that adds hydrogen ions to a liquid. So the more hydrogen ions you have, the more acidic you are. So that's why, like, stronger acids, they're going to have more hydrogen ions, and that gives them actually a lower pH. Bases are going to add hydroxide ions into a solution. And so the more hydroxide ions you have, the higher your pH is, the more basic you are. So this is kind of what the pH scale looks like. It goes from 1 to 14. Sometimes it goes, you'll see it goes 0 to 14, but there's not a lot of stuff that's at 0. But 1 to 14, right smack here in the middle is what we call neutral. Neutral has to be exactly 7, like 7.00. If it's like 7.01, technically that's like slightly basic, okay? Like very, very little, but it is a little bit basic. If it was like 6.99, technically that's slightly acidic. Okay, not very acidic, but a little bit. And then anything lower than 7 all the way down to 0 is considered acidic. Anything higher than 7 all the way up to 14 is considered basic, okay? And the closer you get to the ends, the more extreme you get. So closer to 1 is going to be more acidic. Closer to 14 is going to be more basic. So the things that are here kind of like in 5, 6 area.
Please. There's a safety threat outside the facility requiring a perimeter lockout. Return to your classrooms and ensure all students remain with a staff member at all times.
Okay. Thanks for that announcement. They already told us that, but okay. All right. So back to our lesson. Sorry for that interruption. So anything like kind of here where it's like 5 and 6, and even maybe down to 4, this is where you're going to find the weak acids. because weak acids, remember their definition is that they don't have as many hydrogen ions because they don't all split apart. So remember, when something is weak, that means it does not fully dissociate into positive and negative ions. So, things like milk, black coffee, those are going to be weakly acidic because they have, a little bit of hydrogen ions, but not as many as something like lemon juice or our stomach acid. So our stomach acid is hydrochloric acid, which is a strong acid, and so it fully dissociates. Lemon juice is citric acid, which is a weak acid, but it's going to be stronger than what's in like milk or black coffee. Okay. On the other side, with the bases, things that are here like 8, 9, 10, these are going to be weak bases. So like you got egg, baking soda, hand soap. When you start going closer to 14, this is where you're going to get to your strong bases, like concentrated solution of alkalis. So that would be like if I had a sodium hydroxide solution. Drain cleaner has sodium hydroxide, so that's kind of a common household thing. Bleach is also basic. And ammonia is used in cleaning, and it's also usually found in some like things like Windex or some cleaning solutions. So if you notice, a lot of stuff over here is cleaning stuff. Most everything over here is stuff we can eat. The only thing we eat over here, we eat eggs, and we eat baking soda, but not like spoonfuls of it. We only use little bits of it in like baking. Okay. And we talked at the beginning of our unit about how a lot of foods are acidic, and most things that are basic are poisonous, so we don't really eat them, like soap and ammonia and bleach and drain cleaner and all that kind of stuff. So kind of going on. So this is just giving you more detail over what I went over. So a low pH close to 0 is very acidic because they have a lot of free hydrogen ions. Lemon juice is a good example. And if you think back to the properties we talked about acids, we talked about that acids are usually sour in taste. And so like things like lemons and oranges and limes, that makes sense. The stronger the acid, the lower the pH, okay? The stronger the base, the higher the pH. So that's what I meant by like the stronger things are going to be towards the higher and lower numbers. So if you think about it, right in the middle at 7 is neutral. And then right around 7, you have your weak acids, weak bases. And the further you go from 7 to each end, you're going to have the strong acids down closer to like 0 and 1. And you're going to have the strong bases closer to like 14 and 13 and 14. Okay. The reason that 7's neutral and pure water is pretty much one of the only things that's neutral is because acids by definition have extra hydrogen ions right here. Bases by definition have extra hydroxide ions. If you have equal numbers of hydrogen and hydroxide, that H and that OH, they're going to combine and they're going to make H2O. And so pure water, not like tap water or salt water, just pure water that only has H2O is going to be neutral because all of the hydrogen and hydroxide ions are equal. And so they all combine together and they make those water molecules. So pH is actually a really, really important thing in chemistry because it's used a lot in everyday life. They measure water quality. So if they try to test water quality, usually they're going to use pH. They're going to use some kind of indicators to test the water quality. Doctors use it, nurses use it. They diagnose all kinds of medical problems because if your blood is too acidic or too alkalinic, then that can be an indicator of some sort of problems. And so there's like, if you go into nursing or into medicine or things like that, there's things called respiratory acidosis or respiratory alkalosis or metabolic acidosis or metabolic alkalosis. And they all have to do with the amounts of, the acid, the hydrogen, or the hydroxide in your blood, in your body. And so if it's too far out of the range that it should normally be in, they use that to sort of diagnose possible medical conditions. Farmers and gardeners, because if you're somebody who you garden, the pH of your soil can affect like how well something grows. Certain plants grow better in acidic soil. And so you can add certain things to your soil to adjust the pH and lower it. Some things grow better in alkalinic or basic soil. And so you can add different like fertilizers, different nutrients to the soil that can help your plants grow better or might help some plants grow differently. Like I know in my the flower bed in my front yard, I have hydrangea bushes, and hydrangeas are flowers that they turn different colors depending on the pH of the soil, because the pH is going to affect the color of the petals of the flowers. And so if they are, and I'm trying to remember which color is which way, I can't remember. I think if it's acidic, they look more pink. If the soil is more alkalinic or basic, they look more of a blue purpley color. And so kind of just depending, I don't really like put extra stuff in the soil. So some years when they bloom, they look more pink. Some years they look more blue. And that just kind of tells me like, oh, look, the soil is, you know, more acidic this year or more alkalinic this year. Another thing, in like swimming pools, they use pH to test if the pools are safe to swim in, because they put all kinds of chemicals in there. So they use chlorine, but they use all kinds of other chemicals to balance the pH, to balance the quality of the water so that it's safe to swim in. And if it's too high or too low, like it's dangerous, you don't want to swim in it. And so they keep it at the level that it's good, it's okay for you to swim in, but it will also keep like bacteria and like algae from growing. If you don't have it balanced right, that's when you start having like where the pools start getting like dirty and they look like there's like algae growing and it's all green. Like right now, my pool looks green because it hasn't been working since the winter storm, and it has to be repaired. And so right now it's really green because everything's out of whack. And so once they get all the repairs done, hopefully, then we can add the chemicals back in and we can get it back to where it needs to be. So there is a video here that goes over some more information just about where do we see pH kind of in everyday life, because it's pretty important. And so just make sure that you guys watch that later on. Oh, I clicked the wrong page. Sorry, guys. Let me get back. Okay, so you are going to have a interactive assignment today. So similar to what we did for the strong and weak acids and bases is another simulation. So you can either, if you want to click this link here, it'll open it up in another window, okay? And then once you open it up in another window, it's telling you want to click on what says macro, okay? We're just looking at what does it look like to our eye. We don't want to look at the micro scale, okay? So you'll open it up, you'll click on macro, and then it's going to give you some directions here. So when it takes you to the next screen, you want to, this thing right here is called a pH probe. And so you want to drag and you want to drop it into the solution that's in the beaker, because when you do that, it's going to read, you'll see a number that will pop up here in this box right here that says pH. So a pH meter is, or a pH probe, they're sometimes called different things, but a pH probe or a pH meter is something that can measure pH. It measures the amount of hydrogen ions that are dissolved in the solution, and it translates that to the number for pH. Okay, so it's going to be set here. It's on water, and so water is neutral. And then this drop-down box, you'll be able to change the solution or the substance, and that's what you'll be kind of doing throughout this. A couple things to watch out for. So here's where the pH is going to read. So see, it's been dragged into the solution. So now it's reading. It's at 7, right here in the middle. Okay. There's a faucet here for water. Do not add water. Okay. Towards the end, it's going to ask you to add water and make some observations. But for most of this, you don't want to add water, because adding water is going to dilute it, and that's going to affect the concentration, which will then affect the pH. Okay. So once you have it all set up, it's going to ask you to choose different substances, record their pH, and then you're going to determine, are they acidic, basic, or neutral? So for example, one of the options is spit. And so if you were to select spit on the simulation with the pH probe in it, it's going to show you that the pH is 7.40. Since that is higher than 7, that would be basic. Okay, so remember, anything higher than 7 would be basic. Anything lower than 7 would be acidic, and anything that's right equal to 7.00 would be neutral. So there are several listed here, so you can change, like I said, from that drop-down menu in the simulation and read their pH and then determine how you would categorize it, acidic, basic, or neutral. And then it's going to have you do some more. So let's see, we're going to do coffee, milk, drain cleaner, water, blood, soda, battery acid, vomit, soap, chicken soup. Okay. And then once you kind of go through do those and you check, the last part, or not the last part, but the next part is you're going to use it to rank substances from more acidic to more basic. So starting up here at the top, I want to put whatever the most acidic substance is up here. So most acidic means that it would have the lowest pH. Okay. Number 8 down here is going to be the most basic. So that means it's going to have the highest pH. So you're kind of creating a list or a scale of these substances based on their pH from most acidic to most basic. Okay. This one, it's backwards. You're going from more basic to more acidic. Okay. So more basic means that number 1 is now going to be your higher pH substances, and they're going to go down. Number 8 should be your lowest one. Okay. Now it's this last part's going to talk about, like I said, what happens if you add water. So it says choose any substance that is acidic. So you can pick whichever one you want, and then try to add water to it. And you're going to observe what happens. So you're going to pick a substance that's acidic, and then you'll pull this little plug and you'll see the faucet will turn on. There'll be water coming in and the volume will rise up. And so as the water's being added, watch the pH probe over here. Watch the number. Is it going up? Is it going down? Is it staying the same? Okay, what's happening? Then do the same thing with something that's basic and kind of do the same observation. And then the last one, it says now you're going to choose water. So the last time, so first choose something acidic, second choose something basic. Last time you're going to put it on water, and then you're going to add water and talk about what happens to the pH on that one. The last part, it's going to go through what's going to happen with that water addition. Okay, so it's going to kind of go through why you're seeing what you're seeing and what's exactly happening. And then right here at the very end, there are some practice questions related to pH and the pH scale for substances. Okay. So that is pretty much it for today.